Good morning, friends. In the last lectures, we started more circles means for the analysis about the principal stresses and strains, and we are familiar so now with the constructions about the more circles for the you can say evaluations about the normal stresses and tangential stresses, resultant stresses, and envelope of the obliquity. When the tensile stress acting on the x axis and compressive stresses also, or axis compressive stresses acting on the y axis and the tensile stresses acting on the y axis. So the such type of the three problems I had taken in the last lectures. So today I am taking problems related with the principal stresses. So calculations about the or analysis about the principal stress. So that's why today, please note down today's first problems. A point in a strained material, a point in a strained material is subjected to stresses as shown in figure by using more circles. By using more circle, find the magnitude of principal stresses. Second bit, the directions above the principal plane, the directions of principal plane. Third bit, the magnitude of maximum shear stress. Fourth bit, this is third. Fourth bit, directions of shear stress. Directions of planes of maximum shear stress, and last bit is the normal strains. So this 1, 2, 3, 4, 5. So this scale is 6, 7, 8, 9, and this is 10. So first mark this point as a origin, and by taking this is sigma x, this is sigma x, 3 point, and this is now on this body, this is 20 megapascals. So from that, this is positive, this is 20 So tau equal to 20. Mark this point as a H point because this is positive and this is negative. Tau equal to 20 megapascals. Now join H and G points passing through the C point. Now by taking now by using this scale, 1 centimeter equal to 10 megapascals. So that's why solution first bit, maximum principal stress, maximum equal to, now this distance, measure distance. So this point I will give, this point is a P. Distance or OQ. Suppose this is equal to 2.3 multiplied by 10. This is 23 megapascal. So first point is over. Second, the diameter of the, so this angles. So this is equal to 2 theta. So measure angle AC. So this is point. So that's why ACG. Suppose this is equal to 25 degree. Because this is scales and protector. Third point, magnitude of the maximum shear stress. So this is equal to CR. CR radius, CR. This is CR at 10.5 we consider. So this is equal to suppose this is 3.7 megapascals. So that's why 3.7. You can consider this is 10.7, 107. So this multiplied by 10 equal to 37 megapascals. And 2 theta. Now from these angles, this is given 2 theta S1. Angle GCR. GCR. This is equal to, we can say this is 25 plus 9. Means 115. So that's why theta S7 equal to 57.5 degree and theta S2 equal to 57.5 plus 90, 147.5. Next, normal stress. Normal stress equal to measure distance. This is sigma 1. This is equal to sigma 1 and this is sigma maximum. So in the 4 columns we can see shear stresses in the right hand side. Now we will consider shear stresses in you can stresses shown in figure. These values are sufficient, so that's why I have to stop here because this is also that much is not important, because you understand